Hello, this will be a quick video lesson on how to look at quadratic functions when they're expressed in intercept form, also known as factored form. If you look on my Desmos demonstration, we've got a wandering arrow, we have a1x minus a is one of the factors, b1x minus b is the other factor. So we have the constants. In this case I let a be 5 and b be negative 2. And the coefficients on x are 1 in each case. As you can see when you look at the parabola, first of all the parabola opens up, and that should make sense because we have 1x times 1x, which is positive 1x squared. So it's going to be a parabola that opens up. Furthermore, I noticed that a is 5, and one of my x-intercepts is 5. So we'll have x minus 5 as a factor, which means we have 5, 0 as an x-intercept. Here we have b is negative 2, which means we have x plus 2, and then we have negative 2 as so x plus 2 as a factor, and negative 2 as an x-intercept, or as 0 of the equation. So what's fun to do is, if you're into that kind of thing, you can change the a and b values, and you can see you'll always get a parabola. The only difference is the parabola is going to have different x-intercepts. So you can see the point of having intercept form is you can get or factored form is you can get the x-intercepts right away, and then you can quickly tell if the parabola is going to open up or down. But check it out, if I make a equal to negative 1, now all of a sudden the parabola opens down. And notice the 5.4, which is the b value, when I make a equal to negative 1, the 5.4 stayed, but the 2.5 switched over to be positive instead of negative. So look at here, there was the 2.5, now it's negative, and if I do this, the parabola opens down, and then my x-intercept went from negative to positive. So you can see that the coefficients on x do have a determining factor on your x-intercepts, and they have a determining factor on whether the parabola opens up or down. So you can see if we make the b value bigger, it actually does change the x-intercept. So if I make b equal to 1, my x-intercept is 5.4, and if I make b equal to 2, then my x-intercept is half of 5.4. So there's an inverse relationship between the b1 coefficient and the b constant. So to sum it all up and to make sort of some sense out of this, I want to look at a specific example. Here we have a is 5 and the coefficient on x is negative 1, and so that means I have one linear factor that will be negative x minus 5. Because a is 5, we have minus a, that's going to be minus 5, and then we have negative 1 as the coefficient. And here we see b is 2, that's the coefficient, or b1 is 2, which is the coefficient on x for the second factor, and b is negative 2, so minus negative 2. We end up with a function that can be expressed in factored form. So then, from factored form, we can ascertain what the x-intercepts are supposed to be by using the zero product rule. If f of x was equal to 0, then these two factors must equal 0, and therefore one of these two must be true in order to make the x-intercepts exist. So this is just a matter of doing some quick algebra. Notice I will take the opposite of 5 and then divide by the coefficient on x, and I'll take the opposite of 2 and then divide by the coefficient on x to get my x-intercepts. So we can generalize this result using this form right here. If I have two factors, two linear factors equal to 0, I can find the x-intercepts by solving each of these linear factors. I'll add a to both sides and then divide by a1, or I'll add b to both sides and divide by b1. So you can see in my coding over here, I just made coordinates a over a1 to give us the x, and then f of a over a1 to give us the y, and the y always turns out to be 0. So that's how I managed to get the graph to always show the x-intercepts. So what does this have to do with the work that we're doing? Oftentimes I ask you to make quick sketches of your graphs before you actually do the algebra so you can predict what the outcomes will be. If that's what we wanted to do, I can generalize when I see factored form and make some quick decisions about the nature of the parabola that I'm going to draw. So the first thing I'll show you is that I showed you is that you could just take the constant, opposite of the constant, divided by the coefficient, and that gives you an x-intercept. And then the other thing is, if you take the coefficient on the first x and the coefficient on the second x and multiply them together, if it's a positive number, then your parabola opens up, and if it's a negative number, then your parabola opens down. In this case, notice we had an a of -1 and an a of 2, or a b1 of 2. So 2 times -1 is -2. That means a times b1, a1 times b1 is less than 0, and the parabola opens down, as you can see here. So putting it into practice, suppose I had f of x and it was expressed in intercept form, also known as factored form. Then I can do some mental gymnastics and ascertain immediately that the x-intercepts are going to be 5/2, or -4 over -1, or just 4. So I took the opposite of the constant divided by the coefficient. Opposite of the constant divided by the coefficient produces 2 x-intercepts. I quickly plot those 2 x-intercepts, and then I notice that 2x times -x would give me -2x squared, which means I'm going to have a downward parabola like the one you see here. This isn't a perfect sketch, it's a quick sketch, but now I can see how the parabola is oriented and where it crosses the x-axis, which gives me a lot of important information. If I had a different function, rather f of x equals x plus 3 times x, once again some quick zero product ruling shows x equals 0 or x equals -3, it would be my x-intercepts, and since x times x equals x squared, the parabola opens up, and I have a quick sketch. So seeing quadratic functions in factored form means you have a quick access to the x-intercepts, and quick little inspection tells you whether you're going to open up or down, so you can get a nice little poop swag sketch of any parabola if you are given the factored form. Thanks for watching.